So thank you everyone for attending. This is our second Ascend Engineering webinar. We're going to be talking about customizing your ground control system. We've got a great host today, John Nomikos. He's an engineer over at Ascend who specializes in GCS, and I'm going to hand the mic over to him.
Hello. That was a good enough intro for me, but yeah, I specialize in ground control stations. I work at Ascent Engineering. Um, and yeah, I think that's the only intro I need. Um, so yeah, like probably most of you already know us, but we're Ascent Engineering. We help companies develop, optimize, and deploy advanced UAV systems. And like many of us do different things. Specifically me, I do ground control stations stuff. Um, I don't know, Michael, do you have a more better intro for Ascend Engineering or?
Yeah, I mean, Ascend is a drone integration service
Yep.
provider. So they work heavily in open source, anything from PX4 to ArduPilot, but heavily in PX4. So that entire ecosystem, QGroundControl, MavLink, MavSDK, and PixHawk. They've also developed ACO, which is a collision avoidance piece of software, works with a very affordable LiDAR that will help your drone navigate remotely, taking a little bit of pressure off of operators. So check out ACO. Um, Other than that, they employ talented engineers like John, um, who who aren't trained webinar hosts. So John's going to get better as the details go on, and he gets into what he actually enjoys doing. So just a note, uh, the Ascend was co-founded by Andrew Wilkins and Zachary Lau. You probably know one or both of them, considering how vocal they are on social media. And then also, if you have time, check out our white papers. They go a little bit more in depth on companion computers and external hardware integration. This is our first piece of GCS content, and John introduced himself already. So, all right, let's get to what we're actually going to be talking about today.
Yep. So we're gonna start just by talking about Q ground control. And like then we're gonna go into like the categories of how you might want to customize your own like ground control station based on Q ground control. Some examples, and then basically we will show you like a checklist of, this kind of stuff you might want to figure out before you start delving into customizing your ground control station and then next steps.
Perfect. So let's start with
Yep.
to ground control, the open source GCS.
Yeah, so why would you want to start with QGC over other ground control stations? So Q ground control supports multiple operating systems. Since it's built like with Qt, you can natively build for Windows, Linux, Mac, and Android. And the open source software already is built for all those systems. It has PX4 and ArduPilot support. So essentially, by default, QGroundControl already supports PX4 and ArduPilot and the standard firmware that is involved with that. You could technically use a generic autopilot as well, as long as it follows the Mavlink standard. There's broad hardware compatibility as well. It supports a multitude of hardware and flight controllers. As an example, there's even a firmware flasher on QGroundControl where you can flash the firmware on as an example, like if you have a cube or something like that and you wanted to flash like different version of ArduPilot or PX4, that's built in. And it has a very low learning curve compared to like the other alternatives like Mission Planner. Some people actually have an easier time using Mission Planner, but I think QGC is like very user facing of a ground control station, especially considering it's completely open source and free.
Okay, I just want to take a brief second, John, remind people that
Yeah.
they can ask questions later. Also, I'm going to promote Holden to panelist, and I'm assuming Zach is VZAC. So hopefully we won't have to depromote or demote. Promote to panelists. There you go. All right, perfect. You can continue. Sorry about that.
Yeah. So the challenge, like QGC is designed to be like a one size fits all ground control station for PX4 and RD pilot based UAVs. However, your project may have specific requirements which don't fit into this bubble, such as user authentication, custom data pipeline, security requirements, or you want to like to uniquely display your data or other edge case features. In that case, the best solution would be to create something custom.
Yeah, and you might have seen me post this on LinkedIn just a few seconds earlier before we got started today. But this is a quick mock-up the team did just at my request in very, very short time, uh, kind of rebranding QGC.
Yeah, and I don't want to take credit for this. This is like Holden from our team actually created this. Looks very nice and sleek. Um, okay, yeah, so let's talk about the categories of customization. We won't cover like everything you might want to possibly customize because there's such a wide plethora of things, but we'll talk about like the common ones that we see. So first category is branding and user interface. This is kind of self-explanatory, but if you may want to tailor your ground control station to your specific clientele or your brand or and products, but it goes further than that. The user interface of basic or of baseline QGC is like intentionally generic. You can streamline it to make the process of using it for your customers easier, especially for things they may frequently need to do. Um, or you can completely transform the way your application looks and create something professional that you'd be proud about. And then there's a lot of like different categories when it comes to branding, but there's the basic stuff, which would be like making the color schemes and logos, what your company is, like creating your own visual identity for the ground control station. And there's also like the other part of it, which would be like streamlining the actual experience of the UI and tailoring it to uh, what you specifically want to do. So essentially, like making the process of actually using the ground control station easier for what your customers do most often. And then yeah, the second category would be like data pipelines and integration. So if you have a backend server, you can send real-time data. Oh yeah, well, I should probably explain this one more before I start going into it. But like if you want to facilitate custom data pipelines or integrate with custom hardware, which isn't supported on generic ground control stations, that this category would cover it. So if you have like a backend server, you can send real-time data to it, such as drone telemetry. If you have a client-specific platform, this can be very useful, such as a website where you can remotely monitor flights. Um, then there's like external data sources, very unspecific, but because there's many things that this could be. You could have a custom sensor which doesn't follow the Mavlink standard. Um, you, Maybe you need to connect to like an HTTP REST service. Perhaps you need like radio link diagnostics and you want to pull information from certain devices on your network. Um, then there's configuration automation for existing data pipelines. A lot of setups have specific things like vehicle parameters that people are often expected to set. What if you have multiple vehicle configurations? Whenever you expect users to configure something, you leave room for user error. Automating configuration processes is a no-brainer when you want to save time for users, remove sources of user error, or save company time, which would be spent documenting and supporting users. In a lot of cases, simple is better.
Yeah, and just want to add, this is like a huge unlock if you think about the value of data, especially in large commercial enterprises, being able to connect their data within a scope, limiting it for security and whatnot to the user is probably extremely valuable. So it's nice that even on an open
Yeah.
source platform, you have that capability.
Yeah, and then category three is like camera and payload systems. There could be a lot of things you want to do when it comes to cameras. You can add like custom UI, which might allow you to easily change a camera setting. A lot of cameras may require like custom vehicle parameters to work properly. Like in with personal experience, like if you theoretically like want to support multiple cameras on your drone or multiple payloads, and each payload requires different parameters, um, you might want to make it so that those parameters, like when the payload is detected, it automatically swaps those parameters so that a user doesn't have to do it. Um, you could also like you also might want to show multiple vehicle or multiple video feeds at the same time, which I've done before, and that would just give you more situational awareness while flying. Um, but yeah, there's so many things with cameras you might want to do, and I know that's a huge thing for a lot of people. Oops. Okay.
Did you want to
I
talk
think
a
that's
little
the
bit about
purpose.
gimbal management, or you good to go on?
I mean, like, I feel like the camera and gimbal management are kind of similar, but yeah,
Mhm.
like the automatic, like, you might want to automatically switch parameters for both the camera and the gimbal. But yeah, I think I already kind of covered it.
Yeah, it also comes
Um,
back later.
yeah. And then there's mission planning and automation. So let's say that, a lot of times when you're planning on a mission in baseline Q ground control, it is intentionally generic. But with your specific system, you might have certain types of missions that you want users to plan out, and you might want to make that easier for them. Um, or you might have like some custom waypoint behavior you want to create. There's so many different things you can do with missions in general. Like there's also like so I mean that kind of just goes into automation, but like, you might want to create some like automated sequence for like landing or emergency procedures. Or like let's say you want to just click a button and have your drone like set up a land mission or set up like a very simple land mission based on where it is. Um, the whole purpose of mission planning and automation very often is to just minimize the steps you need to set up a mission. And like streamline the repetitive tasks to make the process easier for users. But even going further than that, the more tasks that you have a user do, especially when planning out missions, the more room for error there is. So a lot of times, it's just useful to make things simpler for users. And if you have if your UAV performs a certain way or does specific things, then you might want to automate your mission planning.
Yeah, especially thinking about proprietary or just flight patterns and waypoint behaviors. Say you survey a specific way, or you have an ISR flight pattern that's really integral. You don't want a user
Yeah.
having to set that up.
Yeah, I mean, like one example I think of is like, what if you have a drone that like its entire purpose is to scan like bridges or something like that, You might want to create like some custom scan mission for that. But there's like so many different things that you can do when it comes to mission automation.
Right, because ultimately we just want to get the data back, right?
Yeah. Then there's connectivity and communication. So like maintaining like a reliable radio communication during flight is extremely important. And often like basic ground control stations like QGC, like they don't have a lot of tools for diagnosing like network issues because the radio you use very often might have like a specific way of doing it. So if if for all your drones you use like a certain type of radio and you want to like support like real-time network analysis or like logging radio information, you might want to create something custom for that. Um, there are many radios which don't even like support like RSSI over Mavlink. So you might want to even add like a custom RSSI display based on the way that you would hit the data pipeline for whatever radio you're using. Um, but yeah, there's a lot of different things with this. I mean, there's also like automatic network setup, like network with networking. Like you might want to automatically set something up, like a comlink or something like that, which like QGC by default supports like automatic connecting, but you might have some, custom port or something like that you're trying to connect over. Um, and then there's like multi-protocol support, which would be like if you wanted to support like a different protocol than what is by default supported in QGroundControl, like um, I know like there are very little cases where you actually want to do that, but if you have a very specific use case that might be useful. And then there's like network security, which is very broad, but also really depends on what you're specifically doing. And then geospatial. So this is a big one that many people find useful in flying. What if you have like a custom surveyed map that you want to display on your ground control station, or maybe you have like high detail proprietary elevation data, geospatial layers, etc. Um, there's a lot you can do in the geospatial space. One easy example I could think of is like, what if you have like a very like high detailed map that has like that mentions certain areas that you wouldn't want to fly in or something like that. That might be a good use case for at creating like a geospatial modification. Um, yeah, there's a lot of things when it comes to this. And yeah,
Right.
now let's go into some of the real world examples. Sorry, Michael, I didn't mean to
No,
interrupt
no,
you.
no problem.
Um, so first example would be like a hot swappable gimbal, which I think I kind of hinted at in the cameras and payload systems. But like, what if you have a gimbal that you want to easily switch out for another gimbal? Um, well, very often these payloads have like specific parameters that you want to set, and if you expect users to manually change it, it's very time consuming and error prone. And on top of that, there are so many parameters that you might have to like reboot the vehicle to set and stuff like that. So the solution for this would be just automatic camera detection when connected. You can add like automatic parameter flashing when you detect a camera. And the goal of that would be to streamline the workflow for end users and like not require them to look through like tons and tons of documentation to figure out what to set every time they want to switch cameras. I mean, imagine how annoying that can be. Um,
And then
yeah.
also situational dependent, right? Do they even have time or the mind space or bandwidth to do that in the fields?
Well, yeah. And does your team have time to support them when they run into issues, Because very often, like if you set a parameter wrong, it might not even be clear that you set it wrong until you fly it and realize your camera's not taking photos while on a mission.
And then,
So yeah,
yeah, finding the bug from there is even more wasted time.
yeah. So next would be like surveying with custom maps. Um, so like often surveying operations require highly detailed proprietary maps that aren't available in standard mapping services. Um, this one we kind of mentioned during the geospatial category, but like it's a very common use case. But like you might want to add like your own geospatial file support, uploading GeoPDFs or overlay files. Um, and the use case for this would be like if you're flying and if you have like maybe a custom surveyed map or proprietary data that you want to show, can be super useful. Um, and yeah, this is a pretty simple case. So I think that's basically all I can think of to mention about it. Then multi-stream video feeds. Um, Currently, by default, QGC like shows one video feed at a time, which is fine for a lot of use cases. But if you have a vehicle with multiple cameras, you might want to show multiple video interfaces at the same time, or maybe even like show a tiny preview of another one or something like that. Um, Really, like this can add like a lot of situational awareness, especially if you have like multiple cameras. Um, and like a potential application for this would be like the slide mentions it, but like maybe like if you wanted like some 360-degree awareness system, like if you have a camera on the front or back of the drone, you can see in all directions at the same time. Um, and yeah, it adds redundancy in general, which redundancy is good very often, especially for safety.
Yeah, and if I've noticed any trend throughout the industry is you're just seeing more and more cameras and sensors added to platforms as much as they could sustain, right? Because more sensors means more accuracy, not only for redundancy, but positioning and everything else.
Yeah, I mean, it also means more data getting sent through your radio, so you have to keep that in mind as well. You have to add what is supported on your platform, or what you're able to support on your platform.
Right. It's a balancing act.
Yeah. The next one would be like one-click mission automation. So very often you might have some like things that take multiple steps that is a pain point in your flying. Um, as an example, like very often, like if you try to plan out like a land while you're flying, that can be super annoying and error prone. Um, but like you could theoretically create like pre-built mission templates like that allow you to just like maybe click a button and create it on the map and upload it like all in one sequence. Um, there's also like just common buttons for common operations, when actually planning a mission. Um, this one is very broad, but there's a lot of different things you can do with it.
Yeah, maybe those custom flight patterns you were talking about before. So like that would
Oh yeah,
be
yeah, that would
something
also
to
be
do.
like a one-click mission automation. You're right. Like maybe a custom survey or something like that. And then custom sensor integration. Uh, a lot of times, a sensor might not necessarily like display everything to the ground control station, or it might have some specific like HTTP, REST API, or Mavlink that doesn't isn't supported through baseline Q ground control. And in that case, you probably need some kind of customization to view the data. Easy example for this in my mind is like, let's say that you have some radar or something that like the only way to actually see the data is through like HTTP. Then you'd have to like basically hit it through the ground control station, or you would need to like maybe add a driver in PX4 or ArduPilot to support it. But yeah, this one is kind of specific to whatever hardware you're actually trying to add support for. And sometimes the answer is not a QGC modification for this, but like other times, if it's just like you want to display some certain data, or there's certain data that's not available that can be, then custom sensor integration might be the answer. And it might involve both a firmware modification and a ground control station modification in many cases. Okay, now we'll talk about like the customization complexity spectrum. And just a fair warning with this one, this is definitely an oversimplification of like complexity because, depending on what you're trying to do, it could be any of these categories. Um, but yeah, let's just go to the next slide and I'll show you. But like, yeah, here are some just examples of like things that might take days to weeks, weeks to months, or multiple months. And certain things in these categories might take different amounts of time, but there's just a generalization. So, the basic UI stuff, would definitely be days to weeks. Obviously, if you have like more advanced UI, that would might take longer. It really depends. But yeah, weeks to months would be like, but yeah, days to weeks, it seems like it's mostly UI stuff and then like simple configuration stuff too. Um, weeks to months would be like custom widgets, camera integration, data forwarding, or like mission template creation. But again, really depends. And then multiple months would be like some of the more complex stuff, like if you have like some complex geospatial integration, or um, basically anything that is not like super like stuff that's not already doesn't already have a lot of support. Um, yeah, that's basically it for this. And then like what should you do to set yourself up for success when preparing to create a custom ground control station? So these are some like questions that you might have when or questions that you should be able to answer before delving into your custom ground control station journey. So like what are some of the pain points which frustrate you about normal queue ground control? Do you have any custom hardware that's different than what's supported by default in QGround control and requires modification? Um, what do you like? What's your vision of what things should look like on your ground control station? Like, what's your vision for your own proprietary software? Sometimes it might even involve like creating some like Figma SketchUp or something like that. And then like what's the future vision for your software? And then that goes into this, which is like, would it be better for you to just contribute to open source versus creating your own proprietary fork? Um, so there's a there's a cost to creating your own proprietary fork, and that cost is that you're going to have to maintain your own software. Um, and very often, like you're gonna have to probably manually update your software too if newer things come out in the open source that you want to pull to your software. Um, so like this slide basically just goes over like some of the like the downsides of creating your own proprietary fork and the downsides of just contributing to open source plus the upsides. Um, so if you have like a few things that just aren't supported yet on QGroundControl that you want to add support for, then that's more of a reason to make an open source software versus proprietary. Um, and when you do contribute to open source, that change is going to be maintained in the upstream software. So you don't have to spend your own resources to like number one, do a lot of testing and ensuring that it works on updates and stuff like that. Basically, that would be handled by the open source. The downside is their changes um, aren't controlled by you, and other people are going to use them. But very often, I find just based on how much I do these like ground control station modifications is that a lot of times a lot of people are trying to solve the same problem at the same time, and there really isn't a lot of benefit to keeping things proprietary in a lot of cases, because I've seen it before so many times where someone might want to add some change, and you know like the open source communities are also working on it, and then there's no purpose of spending time on this proprietary change when it was already being worked on open source. And like there's other cases as well. But yeah, it's kind of a complex question, and it really depends on like what your vision is. Do you want to create something that is entirely proprietary, or do you want to like make something that's slightly proprietary where you're still contributing upstream? Um, I find that very often like sometimes like a mixture of both is sometimes the best solution for most people.
Yeah, I actually just wanted to add to that last point, because I think the last bullet point on proprietary for best for true competitive advantages really is the meaningful one because like there's layers to how much of an impact you going proprietary makes. Like if you're just doing the branding and you're keeping all the functionality close to upstream, uh, you're the
Hmm.
impact of some critical change breaking your evolution path is lower, right? But if you do have a true competitive advantage and you need your software functionality to be completely separate, then you probably already can afford to uh, distance yourself a little bit from upstream, right? You're pretty solid on the engineering side.
Yeah, and like just like one of the major benefits is like, if you contribute something upstream, like it's going to be in every version past that. I mean, assuming it's a good change and like people need it and stuff like that. But um, you get the benefit of having maintenance of that software like supported by the community as well as you maybe. But yeah, it really it's a very complex question in general, like of if you should support open source. I usually think that like in many cases, open source is definitely something that like people should actively contribute to, especially if you're working on a project that is open source. It's just a good thing to do. And if you like see a bug or something like that, contributing it to upstream is also good as well. Um, and if the upstream software changes, like your closed source fork might become like you know uh, a pain to updates as well. So there's a lot of
Yeah,
things.
it's a balance. You have to decide
Yeah.
how much you want to push beyond open source, even if
Hmm.
you do have a proprietary competitive
Yeah.
advantage. But you could also plant seeds that helps move the entire code base forward in the direction you want by contributing. So All right, best practices for success.
Yeah, so here's just some things that you like that are good if you want to succeed in creating your own custom ground control station. The first one is just like documenting your specific needs and use cases and what you want the end result to look like. If you don't have a good vision for like what you want to create, then you're just setting yourself up for failure. And like, starting with your core requirements, what do you like, what's your must-haves and nice to haves? Um, if you just go in thinking like, oh yeah, we should do like everything that we want all at once, you're also setting yourself up for failure. You should have a list of the stuff you want to do in the short term versus long term, and basically plan that out. Um, and that goes to the next point, which is like plan in phases. Um, this is how like software is usually best created when it's iterative. So you know, start with the easy stuff, and maybe create some simple like simple things, and then build on top of those. Iteratively improving on your software is good, and if you plan everything in advance, like a lot of times it doesn't work out, and you're gonna have to just rewrite your plans anyway. So being iterative about it is good. Um, And then the last point, which is something I actually think that a lot of people fail to do, is understand what already works well in QGC. So like actually use baseline QGC and like figure out what's already supported, because a lot of times what people are trying to do is already somewhat supported or just slightly different, but solves the same issue. So if you could figure out like if you know what is already supported, and like if it solves your problems already, that's good, because then you're not going to waste time trying to solve a problem that's already been solved.
All right, just want to remind people we're going to get to question time soon. We're almost done. So if you have any questions, get them ready to type into the chat. So just wanted to remind people to connect with us. You can visit us on our website, ascendengineer.com, or email us directly at info@ascendengineer.com, or call on the phone. Um, and then also, John will be available, I'm sure, on social media if you want to post after the
Yeah.
webinar if you don't get your question in now.